This conference will now be recorded.
Okay, so we are going to start with the deduplication. So before we start with the technical discussion that how deduplication work in Commvault, we will just try to understand what is a deduplication, what is the purpose of deduplication, why we are using deduplication. Okay, so
Okay.
as word suggests, deduplication means removal of duplicate data. Okay, removal of duplicate data. For example, we can try to we can try to understand this deduplication with the help of one example. Okay, let's suppose in your company there are 100 employees. Okay, and all those 100 employees will be having their own mailboxes, right? So those
Correct.
mailboxes are hosted on some storage, of course, in the background. Now
Correct.
let's suppose the HR of your company has sent an email, okay, and that email, let's suppose it has the attachment and everything. The size of that email is around 4 MB, okay, and
Okay.
it has been sent to the 100 employees. When it has been sent to the 100 employees, that means that that single mail will be sent to the mailbox of the 100 employees, right? So that's mean a single mail will be saved 100 time on the storage. That's mean a single mail has taken a space of 400 MB,
Correct.
right? So
Yeah.
if I use the deduplication technology, what will happen in that case? The mail will be sent to the only one of the users mailbox. Okay, for rest
Okay.
of the 99 users, a pointer will be created to that particular mail which has been actually sent to one of the user. Okay,
Okay.
but you will be getting a notification in your mailbox and everything. When you will click on that notification of a new email, that new mail will be open, but in the background it is just pointing to the mail which has been actually sent to one of the email boxes only. Okay,
Okay.
so in this way I have just saved the email only one time on my storage and saving 396 MB of space.
Okay.
Okay,
Yeah.
by removing the duplicate data. So this is what called deduplication. So now we are going to start with, we are going to understand how deduplication work in case of Commvault. Okay,
Okay.
deduplication is divided into two parts. One is your target side deduplication, another one is your client side deduplication. It's not two
Yes.
part, but it's two type. Okay, one is your target side deduplication, which is also called media agent side deduplication in Commvault. Another one is called client side deduplication or source side deduplication. Okay, so first we
Okay.
will try to understand what is a target side deduplication, then we will try to understand what is a client side deduplication.
Okay.
Okay, so in the target side deduplication, look at the diagram which you have on the screen. Let me share my screen. Okay,
Yeah.
so
I think I'm aware of these features actually. Like something like before the back. I mean, it will not transfer the duplicate data over the network. That's something called
well,
target
see,
side duplication. It will
like
maintain. Yeah.
okay,
Yeah.
we will go a little quickly. Okay, but
Okay.
you might find few things new. Okay,
Okay.
so
Okay. Done.
okay, so this, using this example, we'll try to explain the target side deduplication. Okay, first
Okay.
I will explain you the diagram. I have one media agent, okay, and I have taken a
Okay.
drive, like a dedicated F drive for the deduplication database. We have already seen the specification for this deduplication database drive. Okay, now
Okay.
let's
Okay.
suppose this is a disk library that I have in the background to which this media agent will be writing all the data.
Okay.
Now I have a one client for which backup will be taken through this media agent and will be written to this particular disk library. Okay,
Okay.
this connectivity between the client and media agent might be through WAN, LAN, and SAN. Okay, I will
Okay.
create a storage policy, apply on this particular subclient of this client, okay, and start taking of the backup. So when you
Okay.
remember in the last class when we discussed about the backup phases, right? So in the backup phases, we have discussed from 5 to 25%, and then from at 25, then from 25 to 85, it discusses a
85.
backup phase during which the actual
Correct.
backup will start traveling to the media agent, right?
Correct.
So during the backup phase, what will happen? The data which was identified during the scan phase, all of that data will be divided into the small blocks. Okay,
Okay.
the size of each block will be equals to 128K. Okay,
Okay. That's the default one, right?
yeah, that's the default one. We can change it to
Okay.
anything. Okay, in the storage
Okay.
policy setting we will be getting that option. It's a by default 128K. We can change it to 512,
Okay.
512, 256 according to our requirement, but by default the size of these blocks will be equals to 128K. Now, all
Okay.
these blocks, data blocks from the client will be sent to the media agent over the connectivity.
Yeah,
Now,
I have
let's
a
suppose,
little query here. So we have an
yeah,
option in Commvault to start from 4K to maximum 512K, right? So how do we know like what is the best practice for Oracle databases? So is there any value for Oracle
see,
database and file this? Yeah.
yes, right, absolutely right. Like this is what I was people are generally ask this question that what is the recommended, what is the best practices, what is the block size that we should keep? Okay,
Yeah.
so see, it totally depend upon the application. We should not change it
Okay.
on our own.
Okay.
Okay, if you're
Okay.
facing some slowness or there is some problem coming up in the backup performances, you can log a case with the Commvault, and Commvault always recommend to change the size of these blocks according to the applications. Okay, for
Okay.
the SQL and Oracle, there are the few sizes that has been recommended on the documentation. Okay, so I will
Okay.
always recommend to refer to those sizes, but I have used it 512 for your Oracle databases. Okay,
Okay.
most of the
So
time
basically,
when we
this
are
is
going,
global to the. Okay. So this we will be applying it for a storage policy, right? So which is global. We
that
cannot
this
apply
is
it for
specific. Yeah,
individual client.
exactly. See, we will see in the coming up sessions that your
Okay.
deduplication database is actually specific to storage policies if it's not been global. Okay, so
Okay.
if you have a dedicated storage policy which has this dedicated deduplication database, then you will
Mhm.
be changing it on the every storage policy. Okay, it's not a global thing that you can change it. It's specific to storage policies option that you will be getting.
Got it. Yeah.
Okay. Now, let's suppose these are the 6 blocks that we are getting. Okay. Now, these
Okay.
blocks will be received by the media agent one by one. So on
Okay.
media agent, when it receives the first block, media agent will use something called hash algorithm. Using that
Okay.
hash algorithm, a unique identity number will be assigned to this particular data block depending upon what is the data inside that particular block. Okay.
Okay.
Now,
Okay.
unique identity is actually called unique signatures in terms of Commvault. Okay,
Okay.
so I will
Okay.
be saying that when this media agent will receive this block, media agent using the hash algorithm will assign a unique signature to this particular data block. Okay,
Okay.
now this signature will send by the media agent to deduplication database for the comparison.
Okay.
But this deduplication database is blank for the very first time, right? It does not have
Correct.
any information. We have just created DDB. We'll see how to create a deduplication database, but it is blank right now. So DDB
Correct.
will say that I don't have this your signature information which you have sent to me. So media agent will understand by this thing that this particular data block has never been written to my disk library.
Okay.
Okay, so this data block will be written to your disk library, and the signature information of this data block will be noted down in deduplication database.
Okay.
Okay, now
Okay.
the second thing that we have is the second let's suppose when the second data block came up, the media agent using the hash algorithm again will assign a unique signature to this particular data block. Okay, now
Okay.
this signature will again will send to the DDB for the comparison. Now
Okay.
deduplication database will again respond that I don't have this signature because it has a signature, but that signature was for the data block A. So DDB
Correct.
will say that I have a signature, but it does not match to the signature which I have. Okay, so media
Okay.
agent again will understand that this data block has never been written to the disk library. So the signature information will be noted down inside the deduplication database, and
Okay.
your data block, the actual data block B will be sent to the disk library by media agent. Okay.
Okay.
Now
Okay.
same process will be repeated for C and D.
Correct.
Okay, now let's suppose the fifth block is A again. Okay, it contained the exact data which was there inside the block which we received for the very first time. So when
Mhm.
this block will come to media agent will assign the same signature that was assigned to this one because of the hash algorithm. Okay,
Okay.
so now this signature will be sent down to the deduplication database for the comparison. Now
Okay.
deduplication database will say this time will respond in positive to media agent that yes, I have the signature information with me. So media agent will understand that this means this data block has already been written to the disk library. Okay, so media
Correct.
agent will discard this particular data block. Okay,
Mhm.
and will note down will note out the information into the deduplication database that this particular data block was received for the second time.
Mhm. Correct.
Okay, the same thing will be repeated for B. So this is how your deduplication is working.
Okay, so this 128 block is something like, I mean, the okay, let's say if I have a 1 GB of data, so it will be like separating into multiple blocks, and then that blocks, I mean, that will be again sent, right? So that's what you mean block
Right.
or like block.
So 1 GB of your data will be keep on getting divided till it reaches to 128K.
Okay,
Okay.
okay, got it.
Now, there is one example to understand over here. Okay. Now, let's suppose the size of the file, okay, the size of the file was 256K. Okay.
Okay,
In that case, the data will be divided into two blocks of 128K. A unique signature will be assigned to them, right?
correct.
But let's suppose if the size of that signature, sorry, the size of the file is 280K. Okay.
Okay,
Now there will be two blocks will be created, each of the size of 128K.
correct,
Agree? But
correct,
in like 128K plus 128K will reaches to 256. But the size of the file is 280K, right? So we are
correct,
still left with 24K.
correct.
What will happen with the 24K?
Will it create? I mean, in that block, it will be adding the other different file into the same block as a single block,
No,
or how? Okay,
no. So what will happen for the 24K? Again, a
okay,
unique signature will be generated and it will be treated as the entire 128K block. Okay. For the
okay.
24K data, a
Mm-hmm.
unique signature will be generated. The unique signature will be written to DDB and the actual data of 24K will be written to disk library. Okay.
It means that remaining 104 K will be waste only, right? That will be consuming the
Exactly.
capacity.
It will be treated in the same way. Okay.
Okay,
But
okay,
let's suppose the size of the file is 260K. Okay.
okay,
In that case, two data block will be created of 128 each. Okay.
correct,
After that, there is a data of 4K that is left. Okay.
correct.
If the data left is equals to 4K or less than 4K, for that
Okay,
particular data block, no deduplication will be done, and that particular data block will be written as it is to your disk library.
okay,
Clear?
okay. Means it,
Okay.
that single 4K will be written as a raw file without instead of taking
Exactly.
128.
Without any deduplication.
Okay,
Okay. This is how your deduplication is working and treating those data.
but
Okay. Now,
okay. So previously we left with 24K and it has taken the entire 128K block. But okay, so you mean to say without deduplication, we will be taking that 4K block.
right. 4K
Okay,
block, for the 4K block, media agent will not generate any signature. Media agent will see that this is a 4K and this is the
okay,
file, like this is a the size of this particular data block is 4K. So that's why there is
okay,
it will not generate any signature against to that particular data block and will send that particular data block directly to disk library.
okay, 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 got it.
Got it?
So how about if it is 12K, I mean something like that, 12K or 6K, something like that, it will.
Anything greater than 4K will have their own signature. A unique
Okay,
signature will be assigned by the media agent.
okay, okay, got it.
Clear?
Okay, yeah, clear.
Okay. Now you can see on the disk library there is something called, I have written chunk 1, chunk 2.
Correct.
Okay. So in media, in this Commvault, what is happening? See, when it find out this particular data block is unique, okay, media
Okay.
agent is not committing that particular data block instantly to disk library. Okay, media
Mm.
agent will keep on accumulating those data block within itself. Okay, till the
Okay.
time the size of all the block, all the unique block is reaching to 4 GB. Okay,
Okay. Means
once
each
this
chunk will contain up to 4 GB of data.
exactly. So
Okay.
once the 4 GB of unique signatures or unique data block has been accumulated by media agent, then
Okay.
all those 4 GB data blocks will be committed together to inside the disk library. Okay.
Okay. Okay.
So in Commvault, by default, the chunk size is equals to 4 GB, but that chunk size also differ on the basis of your type of data that you are backing up.
Okay.
Okay, the size of that chunk will be different for the SQL. For the SQL, if I'm not wrong, the chunk size is equals to 16 GB.
Okay.
Okay, so how you can verify? See, these are the disk library. Disk library means it is a like on the media agent, they have been configured as a LUN, like if it's coming from this external storage. So you can
Correct.
simply go inside the folder of this particular disk library. If you will try to open the folders inside the disk
Mhm.
library, and you will click on the folder and you will see the size, it will be coming up to the 4 GB or 16 GB.
Correct. So there will be multiple folders will be there inside. If
Exactly.
they get into one folder, multiple chunks will be there basically, right?
Exactly. Inside a folder, there will be one chunk. Okay.
Okay.
Per chunk, there is a folder getting created.
Okay. Okay. That we will see
Okay.
in practical, right? On the next section,
Yeah,
like what is the.
yeah. We'll see when once we are doing the backup, we'll open those
Okay.
files and we will see the size of those files.
Okay.
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 So this is what the chunk is. When we talk about the chunk, we will talk about like this is a certification question as well that is asked by the Commvault, that when is your data committed to your disk
Okay.
library? It's not after
Okay.
the every signature generation. It's when the
Okay.
unique block reaches to this one.
4 GB. 4 GB
Right.
or yeah. Done. Okay.
Okay.
Okay. Got it.
Okay. Now we will try to see the deduplication database now, little on more detail. Okay,
Yeah.
now
Yeah.
this deduplication database, I told you it is going to contain two type of information. The first information it is carrying on is the unique signature information. It
Okay.
also contains the information about how many times that particular signature has been received,
Okay.
right? So this deduplication database is actually having three tables. Okay, not a
Okay.
three table, single tables with three columns.
Okay.
Okay, which is called with the name primary column, with the name primary. The second column is called with the name secondary, and the third column is
Okay.
called with the name zero reference.
Okay.
Okay, now your primary table, like primary column, will contain the information about all the unique signature that has been received.
Okay.
Okay, your secondary table will contain the information about the pointers, that how many times those data blocks has been received. Okay, now
Okay.
pointers, what it exactly means, let's suppose this particular data block was received for the very first time. So this
Mhm.
data block unique signature will be written into the primary and the actual data block will be written to disk library. Now when
Mhm.
this particular data block is received for the second time, that signature information will be sent to DDB and DDB will say that I have the signature information. Okay, so
Mhm.
media agent will say that okay, you have that signature information, but you have to create a little metadata or a pointer stating that this block has been received for the second time. Okay,
Okay.
why it is necessary to note down that information, I will tell you in just in few coming minutes. Okay, so how many times that particular data block has been received, that information will be noted down in the secondary table in the form of pointer.
Okay.
What does this pointer is pointing to? These pointers are pointing to the unique signature which they have in the
Primary.
primary. Okay,
Yes.
so if this particular data block has been received for the 10 times, so there will be 10 pointers from the secondary table that will be created to the unique signature in the primary.
Yes. Yeah. Single
Okay,
signature will have 10 pointers.
exactly.
Mhm.
Okay, now this is what your secondary table is. Now third
Okay.
table, we have something called zero reference.
Okay.
Okay, now what is a zero reference column? In the zero reference column, okay,
Mhm.
it contains the information about the signatures whose retention is completed. Okay, or
Okay.
in a more technical way, since you understand the concept of pointers, in the more
Mhm.
technical way, I will say zero reference contain the signature which does not have any pointers coming up from the secondary table, secondary column.
Okay.
Okay, now what is the use of it? Okay, like how it is working, what why it is containing that information. Okay,
Mhm. Okay.
for example, let's suppose this data block A is there. Okay, and this data
Okay.
block, when I received this data block, it was having a retention of 15 days, for example.
Okay.
Okay,
Okay.
so a unique signature was noted down in the from the primary, pointers from the secondary was pointed to this particular unique signature, and that pointer
Correct.
contained information that this
Multiple
particular
evaluation.
data block was received and it has a retention of 15 days.
Correct.
Okay, now let's suppose when I'm receiving the data block A, this data
Mhm.
block, second time I'm receiving the data block A, this data block might be coming up from the same client or different client. Let's suppose this is coming up from the different client and it has a different retention of 20 days.
Correct. Okay.
Okay, so in that case, in the 20 days retention, when it comes to the media agent will do the signature assignation and everything, and a pointer from the secondary table will be created to the unique signature in the primary. Now that pointer
Mhm.
information will contain that this particular data block, when I receive for the second time, has a retention of 20 days.
Okay.
Okay, now you know about the data aging job, right, which runs
Correct.
every day and prunes the data from a disk library which has completed the retention, right?
Correct.
So what happen is, when that pruning job is running, that pruning job will come to the zero reference table, okay, and it will see what all unique signatures are there. So what happen is, actually what is happening in the primary and secondary table, see, when
Mhm.
the 15 days will be completed, okay,
Mhm.
so the first pointer will be deleted from the secondary table, okay, because
Okay.
it has completed the retention. But the
Mhm.
data block will not be deleted from the disk library because it still contain one pointer, a valid pointer
From the
from the
different
secondary
client.
table, which has a
Correct.
20 days of retention.
Correct.
Okay, so this data block will still remains, only the pointers has been removed from the secondary table. Now when
Okay.
the 20 days get completed, the second
Mhm.
pointer will also get deleted. Okay,
Okay.
so when you run a data aging job, during that
Mhm.
data aging job, okay,
Mhm.
the Commvault will see that how many primary signatures are there inside this particular column which does not
Mhm.
have any pointers coming up from the secondary table.
Okay.
Okay, so it will find out the unique signature of A does not have any pointers coming up on the secondary, coming up from the secondary table after 20 days. So what it
Mhm.
will do, it will move that particular unique signature information to zero reference table.
Okay. So means that if I mean, if I have, I mean, if I don't have any retained data, then that pointer will be moved to the different, I mean, zero reference.
Exactly.
Okay.
Okay,
Okay.
so when it comes to the zero reference, like when it comes to the actual deletion of the data block, so your
Okay.
Commvault will see what all unique signatures are there in the zero reference table, and
Okay.
the data respective to those signatures will be deleted from your disk library.
Okay. Okay.
Is it clear?
Okay. Yeah. Clear.
Okay, so this is how your zero reference table
So
is
which is
working.
something like, yeah, let's say for example, if I browse my disk library, I will have hundreds or thousands of chunks, right? From the
Right.
day one, it will be creating a different chunks. So
Mm-hmm.
during the data aging sum, it will delete my even the first day reference if I don't. I mean first day chunk. If my reference is zero, it will just delete the first day created file. I mean,
Right.
uh,
See, if there is no pointers from the secondary table to primary one, that will
mhm.
be deleted. Simple. Whether it's been from
Okay,
the very first day or second day.
okay, okay, got it.
Okay.
Okay. So
This.
one more thing,
Mhm.
like how I mean how the folders are creating it, because when I get into the folder, it is creating multiple directories and thousands of files will be there actually.
Okay.
So how can we
So see,
identify?
you will not be able to see, you will not be able to identify those files, right? So what will happen
Okay.
when you will go into the disk library, you can just see
Mm-hmm.
the folders each having a size of 4 GB. That's it. When you open those files, they will be in some different format that can only be identified by the Commvault. You will not be
Correct.
able to identify which file has been written into which particular folder, of course.
Correct.
To
And
browse
apart
that,
from
of
chunk,
course, you have
there
to
will be
come to
some.
the Commvault console. Yep.
Correct. And apart from chunk, there will be some other files like IDX and some
Yes,
this
I'm
index.
coming to that point. I'm coming to that
Okay.
point. Okay, we'll discuss those
Okay.
points when we are discussing what happen if your DDB get corrupt. Okay.
Okay.
Okay, is it clear now? Target side
Yeah.
deduplication.
This is clear. Yes. Yes. This is clear.
Okay, now
Yeah.
This is target side deduplication. Okay, a very small thing I just want to explain. You might already be knowing it, but yes, when the hash algorithm is assigning a unique
Uh,
signature to data blocks, to different data blocks, how it is
okay.
doing. Okay, so what are these data
Okay.
blocks? Data blocks are nothing but in computer language everything is combination of 1010, right?
Correct.
So 128k data block, when I say, it is having a 1010 combination of size of 128 kb,
Correct.
right? Now, to
Correct.
understand how hash algorithm is working, let me reduce the size of 128k to 2-bit.
Okay.
For example, Commvault is dividing each and every data block into the 2-bit, which is very small. Of course, it will not do it, but I'm just to
Okay.
explain you how it is assigning that signature. Okay,
Okay.
so what happen is, let's suppose if it is dividing the data block into the size of 2-bit,
Okay.
every, like, there are only four possible combination when it comes to 2-bit:
Okay.
10
Okay.
01 00 11. So hash
Correct.
algorithm will always say, whenever the data block 10 is coming up, I will assign a signature A. Whenever the
Okay.
data block 01 is coming up, I will assign a signature B.
Okay.
Whenever 00 is coming up, I will assign a unique signature C. And whenever
Okay.
11 is coming up, I will assign a unique signature of D. This is how hash algorithm is assigning the data to the different data block. How this is how hash algorithm knows that this particular database is same, and I like this data block is same, and I need to assign this particular specific
Okay.
signature
Okay.
to this particular data
Means
block.
this 128k block. I mean the identical 128k block can be from file system databases or VM. It can be anything, right? Across
Exactly,
the.
exactly.
Okay. Okay.
Exactly. See, they can be from the same data block, but
Mm.
data type is almost different. Like when we say data type, like if you're combining a DDB and your file system, we say that deduplication performance will not be coming up very good, because the probability of matching of these 128k is very less, because
Mm, mm.
data type is totally different. But yes,
Okay.
whatever you said, that is a possibility, and that's the reason why the two data blocks can be received from the two different servers as well.
Okay.
Okay.
Okay. Got it.
Okay, this is what your target side deduplication is.
Okay.
Okay, now we will try to explain client side deduplication.
Okay.
Okay, so on the same diagram we will see, if you enable client side deduplication, what will happen. Okay, if
Okay.
you enable client side deduplication, now for that we have to go back to the target side deduplication, and remember that when we were doing the deduplication during the backup process from 25 to 85%, data blocks are getting divided on the client itself, right? Client
Correct.
software, the Commvault software on the client, divide the data blocks into the size of 128k and send all the data blocks to the media agent, right?
Okay. Correct.
This is what
Correct.
was happening in the target side deduplication. But once you enable the client side deduplication, what will happen in that case?
Mm.
The data will be divided into the blocks on the client itself, plus
Okay.
the unique signature which was assigned by the media agent in case of target side deduplication. That work will be taken care by the client only. So client will divide the data blocks, like will divide the data into the data blocks and will assign the unique signature to them.
Okay.
Okay, once the unique signatures has been assigned, all those unique signature will be sent to media agent. Like all these, only the signature from the client will be sent to the media agent for the comparison. Media agent will compare those signature with the existing DDB and will refer back to the client that these are the unique signatures and these are the repeated signatures. Okay, so the
Okay.
client will send the data blocks, only those data blocks will be sent from the client which has been received by the media agent information saying that these are the unique signatures. So the unique
Okay.
signatures respective data block will be only sent from the client. What was happening in the target side, all the data block irrespective of whether they are on the media agent or not was sent to the media agent, right? But in this
Yes.
case
Correct.
only those data block will be sent over the network which are received as a unique signature information from media agent after comparison.
Okay. Okay.
Clear? So what we are doing
Clear.
is we are reducing the amount of data on our bandwidth, like on our connectivity.
Okay. Okay. Got it.
Got it? Okay.
Okay.
Now, once you
So,
enable the client
will it
side,
impact any performance when you,
yeah,
I mean,
we'll
when you do the
discuss. Yes.
client?
See,
Okay.
what is the advantage of client-side deduplication? Advantage of client-side deduplication is the amount of data sent over the network is reduced. Okay.
Correct.
But what is the disadvantage? The disadvantage of this particular client-side deduplication is that it is putting up extra load on your client, because
Yes.
it is a client, because the number of process has been increased on the client, right? This is a client on which the signatures has been generated, it has been sent to media agent, and then it will wait for the response from the media agent. Once the response has been received, it will filter out all the data blocks and will send only the unique one, right? So there will be a
Correct.
lot of process which will happening on the client side, right? So
Correct.
you require hardware in that case,
Correct.
right? You require resources in that case in terms of CPU and RAM. So
Okay.
it will
Okay.
be
Okay.
putting up load on your client. So
Okay.
if your client is very old, like in terms of hardware and the OS, will not recommend to do the client side deduplication. But otherwise, in today's world, most of the time we are following up the client side deduplication.
Okay. Got it. And we also need to have some sort of temporary storage, right? Till the comparison
We'll
happens.
discuss. We'll discuss.
Okay. Okay.
Okay. This is what your client side deduplication is. Okay.
Okay.
But this, whatever I have explained you till now, will be happening if you have only enabled client-side deduplication. When you
Okay.
enable client-side deduplication, you will be getting few more option. Okay, that
Mhm.
is how to like when you enable a client-side deduplication, below that you will be getting one more option whether you want to enable a disk cache or not. Okay,
Okay.
so what is a disk cache? Let's suppose if you enable that option of disk cache. Okay,
Okay.
by default under the job result directory, okay,
Okay.
by default under the job result directory there will be one folder that will be created of size of 4 MB by default. Okay, remember
Okay.
that you can increase the size of this particular folder, but by default it has been assigned of 4 the size of 4 MB. Okay,
Okay.
so a folder will be created. So what will happen when you enable client side deduplication with disk cache? So what will happen, so the unique signature, like all the signatures which has been generated on the client, will be
Mhm.
first compared with this particular folder. The disk cache will be first compared with the disk cache. Okay,
Okay.
so it is kind of acting as a temporary DDB on the client side.
Got it.
Okay,
Okay. Okay.
which is just specific to for this particular client. So client will do the comparison of signatures with this particular particular local DDB. Once it is not found over there, if the signatures are not found over there, only those unique signature will be sent to the media agent for the comparison.
Got it. So this way we can eliminate the duplicate blocks from the same client.
Right, like in this way the number of number of signature that was sent by the client to media agent for the comparison, that has also been reduced.
Correct.
Okay, so this is what called client side deduplication with disk cache. Okay, but remember that it's not a proper deduplication database. Okay, it's just a
Okay.
simply directory which is holding down your signature temporary, and maximum size, like the size which you have decided is 4 MB. Okay, so once
And
it
will
processes.
the copy of the client DB will be sent to the media agent, because if in case
No,
this
no,
client fails.
that's what I'm saying. That's what I'm saying.
Okay.
That's what I'm explaining. This
Mm-hmm.
has nothing to do, it is not going to be copied anywhere. Okay, it is not going to be
Okay.
backed up anywhere, nothing happening
Okay.
to this particular one. It's just the individual one lying over there, and even if it losses, it does not
Okay.
matter. Like it will come, a client will create again, it will create a temporary DDB kind of thing, like a temporary disk cache over there, store the signature from
Okay.
the scratch. Like for the very first time it will say no signatures has been identified, so all the signature will be sent to the media agent for the comparison. But from the next
Okay.
backup onward, it will be having a signature to compare, right?
Yeah.
Okay,
Got it. Mm.
so this is what called client side deduplication and client side deduplication with disk cache.
Okay. Okay.
Okay, remember that if you want to do a client side deduplication with disk cache, you enable the client side deduplication with disk cache. Okay, in which comparison is also have signature generation and comparison both are happening on the client. But let's suppose in that case your resource utilization on that client is going very high. So in that case,
Okay.
what you can do is you can disable the disk cache and just use the option of client side deduplication, and then see whether the resource utilization is coming down or not. Okay, and if in
Okay.
that case as well your CPU utilization and everything is going high, then in that case you can again reduce, like you can disable the client side deduplication.
Okay. Okay. Got
Okay.
it. And I have one more query.
Yeah.
Let's say, I mean, deduplication is only to back up the data, right? Not to restore the data. So, am I right? Uh,
Sorry, repeat your question.
I mean, deduplication is one. I mean, the DDB database is not required when we do the restoration, correct?
Exactly.
Yeah.
So
So
that
how
we
does
will
it
discuss.
work actually? Yeah. Okay.
Okay,
Done. Done. Okay.
it uses index cache. Okay, restoration
Okay.
process totally uses index cache. I told you that index cache, when we were discussing, I told you what is the use of the index cache. Index cache
Correct.
is used for the restoration. Index cache
Okay.
contains the information about the data blocks where they have been written
Okay.
on your
Okay.
disk
Okay.
library. Okay, so it does not require your deduplication database to get involved.
Okay. Means whatever the secondary pointer we have in a database, I mean DDB database, like the pointers, the same pointers will be written to the index
Will not
also,
say
right?
pointers, will not say
Okay.
pointers. Yeah, but yeah,
Okay.
of course you're right in indirectly way, but it is directly writing down the address of data block A. Simple. Where the
Okay.
data block A was written, when was it was received for the very first time, that information it is containing. But yeah, you can say it's a pointer kind of.
Okay.
Okay,
Okay. Got it.
clear.
Yeah. I'm clear with this.
Okay, this is what called client side deduplication with disk cache.